Okay, hello everyone. I'm Patricia. I'm going to be talking about one of my favorite topics, which is CI/CD security. And it's sort of an approach to CI/CD security. And I want to start with a bit of a disclaimer, okay? Before, when I heard CI/CD security, I many times would think about my scans in my pipeline. Do I have vulnerability scans, IAC scans, misconfigurations? This talk is not about that. So what is this talk about then? Well, when we have engineers working in code, ourselves, developers, we do something on the development workstations, and somehow we end up affecting some apps and services on the other side. This talk is going to be focused on this middle bit, which is CI/CD platforms. And you can kind of tell, or maybe you can't because it's very grayed out, there's kind of a feeling like this is a funnel here, because everything that is in these development workstations ends up on the other side. So, I'm Patricia, as I said. I'm a cloud security engineer, and I really like to talk and write about pipelines and CI/CD platforms. I like to understand them. And because if you understand these things, you can start to attack them. And it's really around, the challenge here is really around balancing security and the usability of these systems, right? Because you cannot sacrifice certain things like usability for your engineers and developers. So my main goal today is to kind of fast track you through some of the lessons that I've learned and some of the mistakes that I've committed throughout the past year or two that I've been working with this. And as a starter, we're going to be looking at the anatomy of a CI/CD system. What do I mean with a CI/CD system? Again, we have our users using their IDEs of choice, AI clients even, and at the end of the day, you're going to put your code in some code repository, in Azure DevOps, in GitHub, wherever you're putting your code. You're then going to run some automated pipelines, automated workflows, and those workflows might be building images and pushing them, pushing those artifacts to some sort of repository up there, an artifact store. And those can be open source, they can be managed, they can be non-managed artifact stores. Somehow, those artifacts end up in your applications and services, in production, in development, sandbox, whichever. Now, there's two core things that we're going to touch on in this presentation. One of them is, you see those pipelines? They have some sort of permissions to what I'm calling there pipeline resources. Those, think of them every time I say pipeline resources, usually they are credentials. And that's going to be a lot of our first part of the first part of this talk. The second part is going to be looking at where those pipelines are being ran. Turns out that they are run in some sort of VMs, in build servers. So the proposal here really is that for an all-rounded CI/CD security approach, you need to focus on two things: pipeline permissions, pipeline access control, there, and build server security. And we're going to start with pipeline access control. And we're going to start with sort of a word diagram that I really like to use to see what a pipeline really is. A pipeline is really just a set of instructions that you can see there. Those instructions are specifying a couple of things: scripts or tasks, commands that you're going to run. And they also declare access to resources. Again, this word of resource. And these resources can be code, can be files, can be credentials, even can signify some sort of compute access. The important thing about the resources is that they usually represent some sort of access to a target service, whether that's on-prem, SaaS, or on your own cloud. The tasks that you've specified are going to use those resources, but they can only use the resources if the pipeline is authorized to use them. So the key thing here to really grasp is that the resources are the things that give the pipeline its privileges. The pipeline itself doesn't have privileges. Another way I could phrase this is when you have a pipeline, that pipeline is going to use a resource, a credential. And by using this resource or credential, I was like, I'm sure I changed the slide to say credential. There you go. So the pipeline uses a resource, a credential, and that credential, that resource, represents access to an identity. Really like this concept. Really like the concept that I mentioned, that this book here, Identity Native Infrastructure Access Management, does. The authors of that book claim that it's kind of a bold claim that there's no such thing as identity theft. What you actually have is credential theft, because they claim identity is a core, as its core concept. You cannot transfer it, you cannot steal it. What you can steal is the representation of that identity, which is the credentials that live as data, because they are data, they can be stolen. It's a bit of a bold claim. I do like it. That's kind of a philosophical observation. I want to do some more practical observations, and I'm going to be picking on Azure DevOps specifically, but we can apply this to any sort of CI/CD system that plays with pipelines and workflows. So imagine you have your pipeline, right? And you create your pipeline, you give it a name. When you run that pipeline once, for example, on 1st of January this year, you get a pipeline execution. That's what I'm calling here a pipeline execution. If you run it again on the 2nd of January, you get another pipeline execution. And bear in mind that this pipeline execution might be running a different configuration from this pipeline execution. Now imagine you're about to press the button to play the pipeline, to run the pipeline, but you haven't really done it yet. What you have is a potential pipeline execution. And it's a potential pipeline execution because at any time you can press play and that pipeline runs and you get a pipeline execution. What's interesting about having pipelines defined in code in your repositories is that your repositories have branches. So what that means is this pipeline here has a specific configuration in that main branch that at any time can become an execution. But I can also create another branch, a feature branch, that has a slightly different configuration of that pipeline. And itself, I can run the pipeline from that branch and create that pipeline execution. That might be equal or different from the one in the main branch. So where do the resources come in here? So imagine you have credentials, and those credentials are stored in some sort of vault or in some sort of service connection. If you're using Azure DevOps, that's what they call it. Those resources, as we said, they're just credentials, and they are credentials that allow you access to some sort of environment, whether that's your dev environment, whether that's your prod environment, whether it's read-only, right. They'll allow you access to something. But right now, it's not really useful for that pipeline. What you need to do is to grant pipeline permissions to those resources. You need to grant the pipeline permissions to those resources. And when you do so, the platforms, or in this case Azure DevOps, will very helpfully tell you that, look, when you create this connection here, that's going to be valid for all future runs of the pipeline. Anyway, okay. So one question that I can ask you is, okay, what's stopping me from misusing those resources? If I can create a branch and do something with those resources, what's stopping me? And you can tell me, come on, it's 2026, everyone has branch protections and everyone has approval gates. And then what I'll ask you back is, okay, are your branch protections and approval gates really doing what you think they are? Because what I'm going to show you next is a way of, and I'll need to press here, and here, right. What I'm doing here is I have a Terraform plan, then I have an approval gate, and then I have a Terraform apply. And what I'm doing is I'm editing from the pipeline file, the pipeline configuration, I'm removing the approval gate. Now, I tried to commit that to the main branch, and I was stopped. So, woohoo, branch protections saved our pipeline. However, what I'm doing instead is, okay, if I can't run the pipeline from the main branch, can I just create a new branch and then run the pipeline from there? And what we can see is that, yes, I can. Because when I press that run button, this time from the new branch, I'm running the pipeline now without the approval gate that I had in the middle. Right? So this really demonstrates that I bypassed an approval gate, and the branch protections that were in place weren't really that useful. So what can we do about this? Well, number one thing that I say when people are applying controls like branch protection is, look, ensure that you're actually protecting something. And they're not just like something saying, oh yeah, I have branch protections, but okay, but I can do whatever I want to do elsewhere. Branch protections work really well for things like GitOps flows, if you're using that, because you can tell GitOps to look at specific branches. But as we've seen, there are situations where those security guarantees don't really apply. Another thing to avoid or to think about is, are you defining controls within your pipeline, within your code, that I can easily just edit out? If you're using Azure DevOps, really do check these approvals and checks. I don't think it's a feature that many people use. It's one of my favorite, I'm kind of a big fan of them, because I feel they're really useful. So you fix all of this, and you're now confident that no one can alter your pipelines. What else could happen? I'm going to demonstrate an example with just Terraform, but honestly, it applies to anything that you're potentially running in your pipelines. And just look at the pipelines as almost like a remote code execution as a service. So essentially, this could happen with anything. But I'm going to show you a specific example where I'm running an otherwise quite trusted tool in a way that is potentially not the best way to use it. So what I have here, right, is a main.tf file, a Terraform file, that is specifying a specific type of resource. It's called a null resource. It's a way that Terraform does say, and HashiCorp do say, do not use it, because you shouldn't be doing this sort of stuff. But I can. And what I'm specifying, right, is in the machine running this Terraform plan and apply, also run these local execution commands. And what these commands are doing is they're essentially exfiltrating all of the environment variables in the context of the build server of the pipeline that is running that Terraform to a remotely controlled repository. In this case, it's me, but it could have been an attacker. And then I end up with the secrets all there. Because you can get to do that, because the pipeline is running with pipeline permissions, highly privileged. So we're all doomed. Or are we? We can do, and we can look out for certain patterns to be a little bit less doomed. One thing that we can look for is overprivileged pipelines. Do you have pipelines that have access to way too many resources, many credentials? That's a bad sign. But don't think that just because you have a single pipeline accessing a single credential, that's any better. Because what you also can have is, instead of an overprivileged pipeline, so that pipeline has access to many credentials, you can have an overprivileged resource. So you have one pipeline that can only access one credential, but that credential itself is accessing everything else. Okay? So the balance here is really something that you need to figure out and decide where you want to draw the line about segmenting the pipelines and the credentials that you're using. Other patterns to look out for are things like, if you have a specific credential or resource that is overshared, is that expected? Some cases, yes, is absolutely expected. You want to share something with every pipeline. Other times, it might be by accident, and you might really need to check that out. Remember the branches that a single pipeline can have, the different configurations a pipeline can have? I mean, if you have 20 branches, can you be sure that all those branches are running a safe configuration of your pipeline? Maybe you're confident with it. So these are things that don't necessarily mean you have something wrong, but are things to look out for. The two main things I would say are important here are, number one, ask yourself what credentials can your pipelines access at any given time, and what privileges are those credentials accessing? So what identities can you impersonate with them? That's pretty much the first side of the talk. It's pipeline permissions is very in the ADO land, Azure DevOps land, GitHub land, up there. We're now going to be looking a little bit more down into build server security. This is almost like more traditional security, I would say. So you can't really tell, again, but there's a funnel that goes from there to there, and this is the core of the funnel. And the reason that's there is because all credentials end up in here at some point. Typical runtime security controls, things like EDRs, so endpoint detection and response, and data loss prevention, vulnerability scans, they are really well understood for the runtime here and for the runtime here, because people understand that the laptop is runtime and we need to defend against this stuff, and people understand, oh, I have a database there and a virtual machine, I need to see what's happening there. The reason I don't like these sort of diagrams too much is because this hides the complexity around the runtime in CI/CD. It's not immediately, you can't perceive immediately that there's some sort of runtime running here. So we're going to look into it. Remember this word diagram? So far, you've done nothing. You've done some configuration in Azure DevOps, you've clicked some buttons, gave some permission to something. What you actually need to do, you need to run your tasks, your scripts, in some sort of build server. They need to be executed somewhere. And for them to be executed there, remember, they are using resources. So those resources, that code, files, credentials, they need to flow down to the build server. Turns out the build server is really just a special kind of resource that gives the pipeline some access to a target service, and in this case, the service will run the pipeline tasks. Why should we care? I've hinted a couple of times, this build server is where at some point, all your credentials, all the things that you care about will end up in. Doesn't matter if they prod, doesn't matter if they sandbox, they will end up there. And sometimes they're a little bit misunderstood. They are unappreciated, and people kind of just let them go and live on their own. So we're going to do a little bit of an exercise to try and understand these build servers. We have loads of users and engineers like myself that can edit and create pipelines. When you do that, you are specifying tasks. Those tasks are going to be scheduled on a build server. Those tasks are things like pull certain images or pull certain artifacts from those artifact stores. Remember, those managed and managed open source artifact stores. You do your stuff in the build server, you might build an image, you might push some artifacts back to your repositories, to the artifactories that you have. You might also be accessing your target services. You might be doing Terraform apply and changing something around these services over here, including you might be telling your cluster, for example, to go get the image that you just built and you now pushed. So what could go wrong here? Like, how would someone even get onto the machine? Which is a question that sometimes people ask. Well, let's try to understand how by attacking this flow. Imagine you are unfortunate enough to have someone that somehow gets access to editing the pipeline, whether they do an account compromise or they're just able to directly edit the pipeline file. What you can do is, in the same way that normal tasks get scheduled on that build server, malicious or potentially malicious tasks are also scheduled there. And they will also be able to pull from those artifact stores malicious or potentially malicious artifacts. What can then happen is you can be pushing artifacts, and this can be kind of two things that can happen. You can be overriding artifacts that your production systems are using. You can be deleting them if you have that access. You can also just be exfiltrating data to an attacker-controlled remote repository. Or you can also, right? You can also just mess with the targets directly if you have that access in your build server, including pulling those malicious artifacts from the artifact stores that you just infected. So what I'm trying to show here is that access to the build server is really just a byproduct of being able to edit a pipeline. You can manipulate these things by doing it. And I'm going to show you, right? And I can show you in any of these platforms. I'm going to choose my favorite one, Azure DevOps. And what I'm going to play here is me demonstrate that in a single pipeline, I can schedule two jobs. One job in a Microsoft-hosted build agent, and this job here is running on my own machine, on the self-hosted build agent. And focusing on this self-hosted build agent, what I'm doing is I'm creating a cron tab entry. Cron tab entry just will say sleep for 300 seconds every day. It's fine. And as I'm doing that, I can see that by the end of that, so this is my self-hosted build agent. It was listening for jobs, and it didn't have any cron tabs entries, but then you can see number 2 here, it ended up with a cron tab entry. Now, if I do the same again, and I'm listening for the second job here, and I complete that job now is saying sleep 150. So what this is demonstrating is that I scheduled 2 jobs, different pipelines, and I was able to persist those cron tab entries in my self-hosted build agent. I can also show you this from another project, and that's what I have here. I'm going to another project in Azure DevOps, which, if you haven't worked with Azure DevOps, is almost like an isolation boundary. So you wouldn't expect a pipeline from other jobs to be able to affect your own workflows from another project. But what I'm doing is I'm adding another sleep, and that sleep is sleep 75. So what I ended up with was 3 cron tab entries. From these 3 pipelines, I ended up with sleep 300, then sleep 150, and then sleep 75. This is really to show that isolation that you might think you have across pipeline jobs and across pipeline and across projects, these isolation boundaries, they can be broken, especially if you're sharing build servers. And that's the key thing. But it's not just by editing these pipelines that you can do malicious stuff. What you also need to think about is what packages are you running on those pipelines, on those build agents? From where are they coming from, and how are you running them? My favorite thing is like using curl -k. Like, who has never used -- insecure? And what I'm going to show you here is using a trusted tool, another trusted tool, not Terraform, not curl, Chekhov. Chekhov is a policy engine. And that policy engine allows you to specify additional checks that you want to run on your code. So I'm going to show you this time in Bitbucket, which is something that I've never actually seen anyone use for CI/CD. But I just want to show you can do this anywhere. What I'm doing exactly here is I have a pipeline job that what it does, it runs Chekhov. And it's going to run Chekhov against a specific image that I have in the repository. And because I'm being good, I'm trying, I want to guarantee that I have my labels applied to my images. So I heard about this open source project that has extra checks for Chekhov. So all I did was specified a very small external checks command line option that allows me to go grab those external checks and then run them against my Docker file. And that works great. Like you can see, I was tagging my stuff, that's why it passed. However, as it was checking if I had my tags, my labels in the Docker file, it also created, exfiltrated all my data to an attacker-controlled repository. And I had no idea about this. And I'll tell you something, Chekhov will actually delete all the code that it ran from that external repository. So honestly, you would not know if this happened to you, unless you're monitoring, which I imagine many people are not. And that was possible because turns out that those external checks are just Python. And you know what? I know a little bit of Python, and you know who else knows a lot of Python? Just ChatGPT, okay? You can get something like this really quickly, really easily. The last example that I wanted to give is when we're sharing things, when we're sharing templates, when we're sharing packages and tools. Azure DevOps has extensions, which are their sort of sharing of templates. GitHub makes it very easy to share templates, and we're going to see an example with just that with GitHub. But what the goal here is to try to convince you that templates and anything that you haven't written yourself or really reviewed should be treated as untrusted unless proven otherwise. And I know it's easier said than done. So let's talk about GitHub Actions. GitHub Actions are frequently shared because it's community driven, it's really easy, it's something that everyone kind of uses and does. They're a bit underestimated, and there's loads of blogs that will tell you about all the security concerns that come with GitHub Actions. Most of them kind of point to supply chain attacks, because you need to ask yourself, are the extensions, the templates that you're using, relying on downstream dependencies that themselves are malicious, or is it that the template is actually malicious? And that has happened, right? Like we've had cases where things like TJ actions and NX stuff happening not too long ago, leaking secrets to the whole World Wide Web. And honestly, when I see those sorts of attacks, I can only think this could have been much worse. Because for example, the TJ Actions one, pretty sure it only affected public repos because it was just pasting it in logs. But I would be thinking, I mean, if it was me trying to do something like that, it could just done much worse. So what can we do when it comes to build servers? And trying not to stop the engineering workflows, because you really need to think, yes, about security, yes, about isolation, yes, about blast radius, but at the same time, performance. And do not fall into the trap of trying to do too much in terms of security-wise, and then your engineering grinds to a halt. So should you be sharing build servers? Well, the security hat on, no, don't share build servers. But it can get quite a mess, and it can get quite hard to manage the balance. So all I would say there is don't let perfect be enemy of the good. Some segregation is better than none at all. I would start, prod, non-prod. That's good enough for now. Build server reuse. Should you reuse build servers across pipeline or pipeline job runs? I mean, ideally, we've seen that you can leak secrets, you can leak processes. I can infect a process, and that process remains on the build server for the next pipeline that is run there. So is that a good thing to do? You security hat again on. Yeah, no, don't reuse build servers for these things. However, if you try to clean them up completely or to destroy them and then get them back on, I can tell you that you're going to have a performance hit, and you're going to have a line of engineers getting really stressed because their pipelines are not running fast enough, at least. My favorite, network access control. I'm really happy with that because I worked a lot on it, and network access control is a funny thing. You have no idea how many URLs and destinations your build agents and build servers are accessing. So getting a hold on that and having an allow list is a hard thing to get to, but I promise you it's really worth, and it can save you a lot of trouble in the future. So if something can infect your machine and then tries to call some random IP, and they can't do that, it's a really good defense. Build server monitoring is another thing that you can consider and that you might be able to invest some time in. Those detections are really hard because think of it, these build servers are meant to run the most different workloads. Everyone does things a little bit different. Engineers engineer their ways out of things differently. It's really hard to get a baseline of what good looks like. But if you can do that, it can be really useful when you're responding to some sort of incident. What if you don't host your own build servers, which is fair enough. I do that sometimes, not for certain projects I do that. And there are some potential benefits that we can get from it. Obviously, you're outsourcing the management of these machines, which they can be hard to manage. You're also getting some security best practices by default, potentially with less of a performance impact because it's just integrated in the workflow, in the service. And because you're not really running them, you're running on someone else's environment, the persistence from them to your environment is almost non-existent because you cannot side travel from them. However, you need to consider some other things. Can you apply DLP on them? Can you be sure that there's no egress from those build servers? Can you apply controls around it? Does it actually fit your use case? Because sometimes you need to deploy to some resource that is locked down to only your networks, and maybe you cannot manage that using that service that the platform is giving you. Can you do monitoring? How's the monitoring and observability on those build server machines that are not in your environment? To be fair, you could just say, I'm not doing that anyway, so I mean, that's fair enough, so you don't care because it's the same, but it might help you choose. Obviously, you need to think about the cost of it, because if you're running on someone else's servers, usually that's also going to be a little bit more expensive, and you need to trust on whoever is running those servers. One thing to realize is that the credentials still end up there. So there's no magic, right? Your credentials at some point will still end up in a server somewhere. And if you don't take the necessary precautions, those credentials can still leak. Okay, so this is the final slide. And I just want to put both of these components of the approach together. And I want to call out that if you focus a lot on pipeline access control and you don't have overprivileged pipelines nor overprivileged resources, and you use reliable controls and all of that, that's really good. But without secure build servers, you're still at risk of some sort of lateral movement and credential theft and artifact theft. And on the other hand, if you focus solely on build server security and you get the network access control, the next network access control good enough, and the sharing and the reusing of build servers as well, even if you get all of that right, without good enough pipeline permission and pipeline access control, you might still be impacting production from non-production pathways. So the conclusion here is that you really need both, okay? And the final thing that I would say is it's a bit of a journey. You need to prioritize. You need to define what good looks like for your environment and focus on practical control. Also, question assumptions, because many things are built on assumptions, and that's what's leading to most of the security concerns I've seen. Thank you. Okay.